Question number 8, we are asked to find the domain of the definition of the function square root 1 minus mod x divided by 2 minus mod x. An elegant question. Let me write again the question. F of x 1 minus mod x divided by 2 minus mod x. Here we have to negotiate numerator separate, denominator separate. It is going to cause us problem for us. Maybe our jeep is going to tumble over. So in order to simplify the situation, making life simple for ourselves, we can divide and multiply the denominator. Divide and multiply denominator. It will become 2 minus mod x, the original one, and divide and multiply as well. By doing this, we have got rid of denominator in square root. There is nothing in square root in the denominator. We have 1 minus mod x, first bracket, it's my mod, 2 minus mod x divided by 2 minus mod x. From this, we have to discard all the values where denominator is 0. So 2 minus x is equal to 0. It gives me x is equal to plus minus 2. X is equal to plus minus 2. So I have to discard x is equal to plus minus 2, because if x is equal to, denominator vanishes, denominator is overall to be 0. If x is equal to minus 2, I plug in minus 2, it will give me also 2, 2 minus 2, still denominator is 0. So x is equal to plus minus 2 are not admissible for the domain of this function. We have negotiated the denominator completely. What about numerator? They must be greater than or equal to 0. In numerator, it might be 0, because overall 0 in square root, in numerator it is equal to 0. 1 minus mod x, first bracket, it must be greater than 0, or 2 minus mod x greater than or equal to 0. It give me 1 is greater than or equal to mod x, or mod x is less than or equal to 1. It gives me the closed interval minus 1 less than or equal to 1. Minus 1 less than or equal to x, x is less than or equal to 1. Similarly, it give me 2 is greater than mod x. This inequality can be written as mod x is less than or equal to 2. It gave me the closed interval minus 2 is less than x, x is less than or equal to 2. Now, take some values. Look, if I take any values from here, this quantity is positive, this is also positive. Okay, concentrate here. Taking any values from here, if I take minus 1 or positive 1, it is 0, overall 0. If I take somewhere, this quantity is positive, this is also positive, this is also positive. So both are positive, 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 positive. We can afford positive sign in that case. So this interval is admissible, 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 valid, valid. What about this one? If I take any value in between minus 2 and 2, if I plug in minus 1.5 here, it will give me 1 minus 1.5. It give me negative 0.5, negative 0.5. Here it will give me positive 0.5 divided, let me write here, negative, by plugging in 1.5 here instead of x, I get 0.5, it's positive 0.5 divided by 0.5 in square root. This is in square root, overall 0 we cannot afford, overall 0 we cannot afford. So this interval seems to be neglected. So our domain of the function must be close interval minus 1 to 1 union. We cannot take minus 2, positive 2, because their denominator ceases to exist, and the values between minus 2 and 2, and the values between minus 2 and 2 our denominator, or sorry, our square root is negative, our square root is negative. So it is our safe side to write discard minus 2, minus infinity to minus 2, all values union positive 2 to positive infinity. And this one is affordable in that case. Minus 1 to plus 1, plug in here or here, overall result is positive, it's good. If in between minus 2 and 2, we have done so, if I put 2 or minus 2, our denominator is 0. We cannot afford, we have already discussed this. If I take any values in between, it give me some negative values. If I plug in 1.5, it 1 minus 1.5, it is negative 0.5 I have written. It gave me positive 0 point divided by 0.5. In square root, we cannot afford negative values. We cannot afford negative values. So I have written, I have deleted this portion, minus 2 to 2. I have deleted this portion from the real lines, minus infinity to minus 2 and 2 to positive infinity, and we have retained once again minus 1 to 1. They are admissible. Clarify the situation by the help of diagram 1, 0, 1, 2 and 3, minus 1, minus 2 and so on. Okay, this interval has been retained. We can take these values. It is in our domain. It is in our domain. This portion is excluded. This portion is excluded. This portion, minus 2 to prior to 1. This portion has been deleted from minus 2 to minus 1. Union, as well as this portion, that is 0, this portion, this union, open interval 1 to 2. These portions have been included from minus 2 to minus 1 and 1 to 2, and we have retained minus 1 to 1. If we take any values in between 1 to 2, whether positive or negative, they gives us this overall square root negative. They will give us overall square root negative. One can plug in any values in between minus 1 to 2. If I have taken minus 1.5, I have clarified the situation. It will give me negative 0.5, and this will give me negative 0.5, and new denominator give me positive 0.5. It is overall minus 1. That's equal to minus iota. Let me give you another overview, making the concept more clear from my side and getting the optimum satisfaction for myself and yourself is this one. 1, 2, 3, minus 1, minus 2, minus 3. Okay, from denominator point of view, this 2 and this negative 2 has been deleted. This is also deleted. We cannot take 2 or minus 2. Here denominator ceases to exist. This is our valid portion. This is in our domain. These are valid values. Okay, portion from minus 2 to minus 1, we cannot afford them. Deleted. This portion has been deleted. This portion deleted, including minus 2. Minus 2 to minus 1, they have been deleted. And this one, positive 1, including, no, excluding. 1 to positive 2, they have, this portion also have been deleted. All, it is inadmissible, not in domain. So we have written the domain in that fashion: minus infinity to minus 2, union 2 to infinity. It is our big chunk, but we are missing this one, minus 1 to 1. They have been retained once again. This closed interval is in our domain. This closed interval is also in our domain. This strip from 1 to 2 open interval, this strip is not included in our domain, as well as this strip from negative 2 to negative 1 open interval, negative 2 to negative has also been deleted, not in domain. So this is the domain of our function in that case. Moving towards next question, we have